Good morning, students. Today's lecture we will see the problems of quartile deviation, especially of continuous series. In some last lectures, we had the problems of individual series and discrete series, as we interacted earlier that in this particular unit number 2, we have to see different methods of dispersion, and in those particular methods, it is my own practice that I will experience the students of various series, individual, discrete and continuous series, because it will be helpful to them to have the idea, have the experience of the subject properly. Though we have to solve the MCQs only in Nagpur University summer 2021 examination, but again, as a commerce student, you should have at least the flavor, the experience of this particular subject. Though we have the limitations in online platform delivery, we have the limitations in particular numerical subject, because in numerical subject it will not that much easy to deliver the contents. So with the help of these notes, with the help of these reference notes, textbook notes, I try to deliver the essence of this particular topic to you. In last lecture, we have the discrete series and individual series of quartile division, coefficient of quartile division. This particular lecture is devoted only for continuous series, because I think continuous series is more important than simple series and simple, or either you will call it as an individual series or a discrete series and discrete series. So in particular continuous series, first we will go to the problem, and then we will see whether that data is being arranged properly or not. If it is not arranged, then we have to arrange in ascending order. Then, as we did in a median, we have to calculate the cumulative frequency. After that, we have to calculate the Q1, but again it is actually a continuous series, so you don't get the exact answer of Q1. So for that you have to apply a formula, then you will have the exact answer of Q1. So that is one thing. Then again you have to calculate the Q3. Again you don't have that exact answer, because you will have a group. With the help of that group, you have to calculate the exact answer of Q3. So having the answers of Q1 and Q3, you will have to calculate the quartile deviation and finally coefficient of quartile deviation. So this way, this is a plan of action of calculating QD and CQD. So first we will read the problem. We will see whether this is being arranged properly or not. So as observing the thing, it is being properly arranged, so there is no need to arrange it properly again. So 12.5 to 17.5, 17.5 to 22.5, this way 47.52. okay, it is being properly arranged, so there is no need to reshuffle the frequency also, because the classes are being properly arranged. So we will go to a solution now. We have to prepare the 3 columns here in that table: class, the original frequency, and a new frequency that we have to prepare, that is the cumulative frequency. So we just wrote the classes as it is. It will have the lowest limit 12.5 and the largest limit 52.5. Frequency as it is. Cumulative frequency, so 1 plus 6 7, 7 plus 4 11, 11 plus 3 14, 14 plus 14 28, 28 plus 19 47, 47 plus 22 47 plus 2 49, 49 plus 20 69, 69 plus 2 71. So the cumulative frequencies are 1 to 71. So the total of frequency will be n equals to 71. As you will see, we had already did the total here, so there is no need to waste your time. So the last thing of this particular column will be the total of this frequency. So we will move to the exact solutions now. We say, so first we have to calculate the Q1. Q1 equals to size of n divided by 4th observation in arranged data. Size of the value of n is 71. 71 divided by 4th observation in arranged data. Size of 17.75th observation in arranged data. Now we have to locate that 17.75th item in this particular cumulative frequency, and after seeing that, you will see it, after locating it will be 28, because 14 will be less than 17.75. 47 will be high or more or greater than 17.75. so the ideal thing and the exact value for this is 28, and the group will be 32.37.5 and the original frequency will be 14. So these data sets are very important for us for moving ahead. So Q1 group equals to 32.5 to 37.5. The difference between them is 5. Now we have a special formula for us here. With the help of that, we will have the exact answer of Q1. Formula equals to L1, that is a lower limit, plus n by 4 minus C. C is actually the previous cumulative frequency, divided by F. F is actual frequency of that particular group, multiplied in bracket L2 minus L1, upper limit minus lower limit. So now we will put up the things in this particular formula. L1, the lower limit, that is 32.5, plus n by 4, we already calculated n by 4, so there is no need to calculate again. It is 17.75 minus C, cumulative frequency, previous cumulative frequency, it is 14. So we wrote here 14, divided by frequency, original frequency is 14. So here it is also we had 14. So don't get confused that here also 14 and there is also 14, because previous cumulative frequency is 14 and original frequency of that particular group is also 14. So he mentioned here 14 in bracket L2, the upper limit of that particular group 37.5 minus lowest limit of that particular group 32.5. So we had placed each and every item in that formula. Then we have to just follow the arithmetical procedures, proper procedures of calculation of this type of equations. Just a general knowledge about arithmetical way of solving the arithmetical problems. You just have to first solve the brackets. Okay. Then you have to solve the divisions. Then you have to do the multiplications. Then you have to do the additions, and lastly you have to do the subtractions, but in a proper way. Only then you will have the answers. Otherwise, if you just solve whatever you want, then you don't get the exact answer of this type of arithmetical equations. So you have to properly follow this sequence. So answer of Q1 is 33.84. Now we have the answer. We have to follow the Q3 also here. Q3 equals to size of 3 n by 4th observation in arranged data. We already calculated n by 4, so size of 3 17.75th observation in arranged data. Size of 53.25th observation we have to locate. So we will just go to the previous slide. That 53.25th is being here in 69. Group is 42.5 to 47.5. Original frequency is 22 and cumulative frequency is 47. So this information is going to be used by us for the Q3. So Q3 group 42.5 to 47.5. Okay. So we have the formula L1 plus 3 n by 4 minus C divided by F, L2 minus L1. L1 42.5 lowest limit plus 3 n by 4 we have already calculated 17.75. Or already you can directly write 53.25 minus C, previous cumulative frequency, that is 47, this one, okay, divided by original frequency, this one 22, in bracket 47.5 minus 42.5. After solving this entire calculation, as I had briefed you about arithmetical sequence, Q3 equals to 43.92. Now we have the answers of Q3 and Q1 with us. Q1 is 33.84 and Q3 is 43.92. Just we have to place the answers in our formulas. QD equal to Q3 minus Q1 divided by 2. 43.92 minus 33.84 divided by 2. So the answer of QD is 5.04. And the next thing that we have to calculate is coefficient of quadrant deviation. So we just put up the things here and the answer is 0.13. Okay, so this way we have to solve the problems of quartile deviation and subsequently coefficient of quartile deviation. So I hope you understand the second method of dispersion very well. The first method that we had completed in previous lectures was range, where we calculated range and coefficient of range. We are here in unit number 2 of dispersion. And the second method that we just had finished is quartile deviation. In that we have to calculate quartile deviation and coefficient of quartile deviation. So I hope you understand this second method of dispersion very well. Next lecture we will have a new method of dispersion. Till then, thank you.